Hi there. Chemical equations vary from very simple ones to much more complex ones. And in chemistry, we cannot do a lot without talking about chemical equations. And so, it's a matter of fact that every student needs to know how to write a chemical equation. This is Z Online School, and in this video, we'll be looking at how to write chemical equations. We are going to do it in a systematic way. And so, by the end of this video, you should know what chemical equations are, the types of chemical reactions, how to form chemical equations, and at the end of this video, we've got bonus tips. So, stay till the end for you to get the maximum value from this video. As you can see, a chemical equation is just a symbolic way of representing a chemical reaction. Elemental symbols are just those symbols found on the periodic table that represent each element. Every chemical equation is made up of the following two parts. The reactants, which are the compounds or elements that are reacting together, and then when these react in a chemical reaction, we are going to have products. So the products are the result of the chemical reaction. These two things are the basic parts of a chemical equation. And every chemical equation has some reactants and some products. One last thing you should know about chemical equations is how they are represented. There are basically two ways in which we can represent a chemical equation. The first one is a word equation, and the next is a symbolic equation. It's very common for you to be asked to write symbolic equations, and in this video, they are the kinds of chemical equations we'll be looking at in depth. Now, let's look at the types of chemical reactions. There are three kinds of chemical reactions that you should know basically. Under chemical reactions, we'll look at these three in much more detail. However, we'll just run through them briefly even in this video. A synthesis reaction is a reaction where we've got two elements or two compounds coming together to form one compound or substance. This kind of reaction where calcium is reacting with chlorine to produce calcium chloride is an example of a synthesis reaction. In a synthesis reaction, we usually only have one product. The next kind of chemical reaction that you need to know is the decomposition reaction. This kind of reaction is just the opposite of a synthesis reaction. So we've got one substance being broken down into other simpler substances. For example, calcium carbonate can be decomposed into calcium oxide and carbon dioxide. There are many kinds of decomposition. For example, you might hear about thermocatalytic decomposition and double decomposition. Like I was just saying, more about these chemical reactions will be talked about under the topic of chemical reactions. Last but not the least, we've got displacement reactions. The first kind of displacement reactions is a displacement reaction where only one thing is displaced. As you can see, A displaces B because B was bonded with C. But now after this chemical reaction, A is bonded with C. The following chemical reaction is an example of this kind of displacement where only one thing is displaced. When chlorine and potassium iodide are reacted together, potassium chloride and iodine are the products. So in this kind of chemical reaction, if you analyze with me, you can see that the chlorine is displacing the iodine. Why does that happen? In displacement reactions, one of the major factors that causes something to be displaced or not to be displaced is the reactivity of a particular element. Therefore, we can say that chlorine is more reactive than iodine for it to be able to displace iodine. And speaking scientifically, that's just true. When you look at the periodic table, this will even make much more sense. This kind of displacement we're just from looking at is called single displacement. Why? Because only one of the elements is displaced. We have another type called double displacement. In this type, it's like there's a switching of elements happening on the product side. As you can see, A was bonded with B and C with D. But because of reactivity in these compounds on the reactant side, after the reaction, A becomes bonded with D and C becomes bonded with B. When we talk about chemical reactions, it will make much more sense. An example of a chemical reaction which is a double displacement is this one shown here. Magnesium chloride, when reacted with potassium iodide, will result in us having potassium chloride and magnesium iodide. As you can see in the earlier example on single displacement, chlorine displaces iodine. So the potassium will want to be with the more reactive nonmetal. With that said and done, now let's look at forming chemical equations. I'm sure you've been waiting for us to start forming these chemical equations. And now we're going to look at the 4 major steps that are very important when handling any chemical equation. The first step is identification of reactants and products. You cannot do a lot if you don't know the reactants and products. And so the first step is you being able to identify what is reacting and what is being produced. After you know what those particular things are, then we go to step 2, which is making the chemical formulas for those compounds that are reacting and those compounds that are being produced. Sometimes it might not be compounds reacting, it might just be elements. And in such instances, chemical equations will be very easy to be formed. However, the examiner knows that that's very easy, so they will make sure chemical formulas are involved. Step 3 involves you being able to write the chemical equation. After you write the chemical equation, one very important step is balancing the chemical equation. If your chemical equation is written with the correct chemical formulas, but you haven't balanced it, you won't get the full marks. And in the most unfortunate situation, you might not even be awarded any marks. Let's look at 2 examples to know how we can form chemical equations. In this example, we've been told sodium nitrate when reacted with lead 2 oxide produces sodium oxide and lead 2 nitrate. As we may know, we are trying to write the chemical equation for this reaction. Our first thing is finding the reactants and the products. How do we locate the reactants? We look for this word react. When we know where this word is, we get closer to our reactants, because we know if they use react, the reactants might just be before and after this word. As you can see, this word react is used with the compounds sodium nitrate and lead 2 oxide. Therefore, the reactants are sodium nitrate and lead 2 oxide. Next, to find our products, we look for the word produce or produced. In this kind of question, they've used the word produces. And after that, we can easily conclude that all the compounds mentioned after the word produce are the products, meaning sodium oxide and lead 2 nitrate are the products. Now, our next thing is just forming the chemical formulas. In our video about how to write chemical formulas, we've covered how to write chemical formulas. And so, in this video, we'll assume you've already watched that video. Sodium nitrate will be written like this, and lead 2 nitrate will be written as follows. You should note that when writing these chemical formulas, you have already used the periodic table. In your exam, your periodic table will be at the last page of your question paper. After After these two react, we've been told sodium oxide and lead 2 nitrate are produced. Therefore, this is the chemical reaction that's occurring. Sodium nitrate reacting with lead 2 oxide, producing sodium oxide and lead 2 nitrate. Now, one major thing is left. You might guess it, and yes, that is it. It's balancing. We haven't balanced this chemical equation, so we need to just do that. To get an understanding of what balancing is, I'll be using these rectangles to show the number of atoms on our reactant side and number of atoms on our product side for each element. We've got sodium, nitrogen, oxygen, and lead on our left side and our right side. And we're going to count the number of atoms on each of the sides. We're going to start with sodium on our reactant side. Sodium has only got 1 atom. Nitrogen also has only 1. Oxygen has got 4. If you see, in this sodium nitrate, we've got 3 oxygen, and in this lead 2 oxide, we've got 1 oxygen. Therefore, oxygen will be 3 plus 1, giving us 4. We only have 1 lead this side, and so we've got 1 atom. On our product side, we've got 2 sodiums, 2 nitrate. You can see there's a 2 outside here, meaning this 2 is affecting both. This is usually done so that we can easily identify the compound being used. If this was written as N2O6, it would be very difficult to identify that nitrate is actually the radical being used. And so, to avoid that, this 2 is just put outside brackets. But when now finding the number of atoms, we should remember that this 2 affects each of the elements inside the brackets. Oxygen becomes 7 because we've got this other atom which is bonded with sodium oxide. Lead is still 1. Now, if we compare the values of each atom on the reactant side and the product side, we'll see that the only element that is balanced in this chemical equation is lead. And therefore, we need to make sure the number of sodium, nitrogen, and oxygen are the same on the reactant side and the product side. How do we do that in chemistry? What we're going to do is something simple. We're going to insert numbers before these compounds. We're not going to do it for each of them, but we're going to choose which one will be appropriate to put a number before so that everything balances. Balances meaning we've got the same number on the reactant side and the product side. When answering any question in chemical equations, we look for hints in the chemical equation. And the hint here is just the 3. We've got 3 oxygen here and 1 here, giving us 4. This side we've got 6 and the 1 giving us 7. So the easiest way is us finding a way of making this number of oxygen in this compound 6. I hope you got that right. Since we've got 6 here being added with 1, while we've got 3 being added with 1, we can say that we only need to find a way in which we can make this oxygen 6 so that it balances with the way in which we are adding on our product side. The hint here is 6. Since we're adding 6 and 1 to get 7, even on our reactant side, we can try to find the way of adding 6 and 1. And that way is just by adding a 2. So if we add these 2, we're going to have 6 oxygens. And therefore, if we add 6 and 1, our oxygen will be balanced. To just check through, I'll write the values in this rectangle of ours. Sodium is 2, nitrogen is 2, oxygen is 7, 2 multiplied by 3 giving us 6 plus 1, and we have 7. We didn't touch lead, so nothing changes. We go to our product side. We didn't touch anything about sodium, as you can see. Nothing here, and nothing on the product side. As you can see now, our chemical equation is balanced by just adding these two here. Actually, what happens here is we've got invisible ones before these others. But don't worry, we'll talk about more of such thinking under more concept. We've got another second example to just make sure you know how to form chemical equations after watching this video. The question reads that in the extraction of vanadium, magnesium is reacted with vanadium 3 chloride to produce vanadium and magnesium chloride. Write a balanced chemical equation for this reaction. The previous question we answered never involved the word balanced. However, I'm telling you this, never leave your chemical equations unbalanced. We just need to identify the products and the reactants. We're going to look for the words react and produce, or reacted, reacts, produced, or produces. Magnesium is reacted with vanadium 3 chloride, so we know our reactants react, magnesium, react, and vanadium. So these two are reacting to produce, they produce vanadium and magnesium chloride. So we know what our reactants and products are. The next thing is forming the chemical formulas for the respective compounds and elements. Okay, now you notice that step 2 and 3 are being combined. Why? It's rare that you start showing your examiner how you are forming the chemical formulas. You should be able to do them mentally. If this is too difficult for you, what you do is just get a pencil and form the chemical formulas somewhere near where you're answering such a question from. Then after you're done, you rub out the pencil. Okay. Magnesium is Mg, vanadium 3 chloride will be written as follows. And then we are having vanadium and magnesium chloride. Now we have all our compounds and elements written as a chemical formula or as an elemental symbol. Now, just like we did, we need to find a way of balancing. These are the elements involved: magnesium, vanadium, and chlorine. We're going to see if they are balanced at the onset. Okay, we were very close until we found out that chlorine is what is not balanced. As we did for the previous example, we're going to see if there's anything in this chemical equation that can give us a hint. Chlorine is what is not balanced. So we go to the chlorine in this chemical equation. We've got the chlorine on the product side in magnesium chloride and the chlorine on our reactant side with the vanadium 3 chloride. As you can see here, we can simply find a way of expressing these two on our left side, or simply find a multiple of 3 and 2 which is common. And as we may know in mathematics, finding the lowest common multiple is just done by multiplying two numbers. 2 and 3 multiplied will give us 6. So we should find the number that we can multiply by 3 to get 6. And we already know that number. It's 2. On this side, we also find the number which we can multiply by 2 to get 6. We already know it's 3 because of this side. And now we check if there's anything else we need to alter. You can see as we put a 2 here and a 3 here, something changes in this chemical reaction. The values of magnesium and vanadium. So by us putting a 3 here, we need to put a 3 on magnesium here also, and a 2 for vanadium. Like this, our chemical equation is balanced. We'll check through our values just to be sure. Magnesium has got 3, vanadium 2, chlorine 6, and we see if even on our product side that's true. And yes, it looks like we've balanced this chemical equation. Thanks for reaching till this part of the video. You have successfully reached the bonus tip section. In this section, our first tip is about state symbols found in chemical equations. This table summarizes the state symbols you'll find. The first one, like you can see, is the solid state, the liquid, gas, and then aqueous. These symbols here are the ways you find these states represented in a chemical equation. Don't worry, we will see how we use these symbols. Now, solid we know is just a solid substance. Liquid is also just a liquid substance. Gas we know is gaseous substance. So the only problem some students find is aqueous. Aqueous simply means something is dissolved in water. For example, if you get salt, which can be sodium chloride, and dissolve it in water, you are going to have aqueous sodium chloride. Tip 2 is about the basic use of state symbols. Let's say iron 3 oxide reacts with carbon monoxide and produces molten iron and carbon dioxide. If we're asked to write a balanced chemical equation to show this reaction, including state symbols, it's very easy. As we did in the previous examples, we're just going to identify the products and the reactants. The reactants here are the iron 3 oxide and the carbon monoxide. Products are the molten iron and carbon dioxide. What you must note in questions that ask you to find or write state symbols, it's rare that the states of these compounds will be given to you. Usually, there will be other topics in chemistry that will enable you to find the state of a particular compound. Now, because we haven't done those topics right now, what I decided to do is get very simple kind of question where we can use general knowledge to identify the state symbols. Here we can all agree that iron 3 oxide is a solid because it's iron ore, and the ore is in the form of a stone, which is a solid. And we can also agree that carbon monoxide is a gas and carbon dioxide is also a gas. The only thing we're left with is molten iron, but don't worry, you know it very soon. These are the chemical formulas for each of these compounds involved. As you can see, we've already even formed the setup of this chemical equation. What we need to do is balance. Now, I told you you would know the state of this iron, which is called molten. I'll just explain why it's liquid. It can't be aqueous because it's not dissolved in water. And when we say molten, it just simply means this iron has been melted till it becomes a liquid. I'm sure that simple explanation has answered your question why we've said this iron is liquid. It's because the iron that was solid now has been heated so high that it fails to remain a solid and becomes a liquid. Okay, now we use our tables again and see how these number of atoms are distributed. Iron on our reactant side is 2, oxygen 4, the 3 and the 1 here. Carbon is 1. Then we go to our product side. We got 1 iron atom, 1 carbon, 2 oxygens. Okay, I'm sure now we're home and dry with the numbers. We are just left with finding the clue. Okay, let's see what happens here. This question is very nice and interesting. It's not difficult, you just need to find the clue. Okay, we don't need to balance the carbon, as you can see, so we don't get concerned about it yet. We only get concerned about the iron and the oxygen. We can also remove our concern about the iron by just simply adding a 2 here. and our iron is balanced. Now we're only left with oxygen. How can we do that? Okay, I think I can see something here. If you look at these three, you understand that we can find a way of manipulating the answer here so that when this 3 is added to a certain number, it will be equal to the total number of oxygen we have here. And I think we can use the number 3 itself, because if we use 3 here, it's going to give us 6 oxygen atoms. And immediately when that happens, it means we need the 3 here. And you see it balances just like that. We've got 6 oxygen atoms on our reactant side, 3 carbon atoms, as you can see. Then we go to our product side, we've got 6 oxygen atoms once again, 3 carbon atoms, and 2 iron atoms. This is very nice. Our chemical equation is balanced. As you may have seen, we look for hints in the chemical equation when trying to balance. Thanks for reaching till the end of this video. Now go out and see if you can answer any other questions about chemical equations.